Alternative assignment, code interview 2. Lesson 7, leveling up with loop and logic. Today, we're going to completely level up your ability to write code. We're finishing our discussion on branching and jumping into a brand new superpower, looping. Think about our programs used to run. They start at the top and end at the bottom. This is a sequential logic pathway. Then we learned if statements, which gave our code the ability to make decisions. But what if you wanted to do something over and over again? In video games, you don't just swing the sword once. You keep swinging until the boss is defeated. In programming, repeating an action gives us a new pathway called looping. Today we're focused on the while loop. A while loop checks a true or false statement. If it's true, the code block runs. Once it hits the bottom, it jumps back up to the top and checks again. To safely control this so it doesn't run forever, we use a Centauri variable. Think of a Centauri like a guard at a post. Their job is to control when the loop should run and when it should stop. We also have a way to make sure the player actually types an attack instead of hitting enter, which is called validation. And finally, we can speed up our code using shortcut operators like the minus equals to instantly subtract health and operator chains to check if attack power is valid. Now let's go on to the Python. Now that we know the theory, we can see it in action. Right here at the top, our Centauri variable is boss underscore HP equals 50. Our loop says while boss HP is greater than 0. As long as the boss has health, the gate is open and the battle keeps on running. Look at the inside of the loop. While not attack name. If the player hits enter, it saves an empty string, which equals false. By adding the not operator, we flip the false to a true, which triggers an error message and forces them to try again. Down here, we chain our operators with 1 is less than or equal to attack power, which is less than or equal to 20. To make sure the attack is fair, and we use our shortcut minus equals to drop the both health here below. And then here is the code running. So it says a wild dragon appears. It has 50 health. It uses an F string to import the variable both health into it. We are in the while loop where it says next turn. And it is asking us to type your attack name. I'll type in fireball. Now down below, it skips the not attack name since I actually typed it in instead of pressing enter, and the string is not empty. It checks the length of the string I input, and it types out that I use a level 8 spell, when which is the length of the word I typed in. Escaping the loop and checking inventory. Today we're getting trapped in a loop on purpose and learning how to break out. We're also looking at for loops, which is basically your program's way of checking its inventory. First up, the intentional infinite loop. We write this as while true, there is no Centauri variable here. Since true is always true, the loop will run forever. Why do we do this? Imagine a game menu. You want it to run continuously until the player specifically hits quit. To make the loop stop, we use a new keyword called break. The moment your code hits break, it completely escapes the loop. Next, we have for loops. If a while loop waits for a condition to change, for a loop is on a strict mission. It runs a specific number of times. A simple for loop looks at every item in a list one by one, like hovering over an item in your backpack. A complex for loop looks at the index numbers of those items, and a fixed length for loop just runs a certain amount of times. If a boss has a 3-hit combo attack, we use the fixed loop to run the attack code exactly 3 times. Now let's look at the Python. I'm going to show you exactly how the loops look in the code. Here at the top is a fixed length loop for I in range 3. This tells Python to run the code exactly 3 times for a boss combo attack. Below our simple for loop, we have a list called inventory, and we use 4 items in inventory to print out everything we're carrying. And finally, let's look at our main menu. It states while true, it will endlessly ask for a command, but the second we type quit, it breaks the statement, immediately killing the loop so the game can shut down. Now, let's see this in practice. Here in the fixed length loop, it says print the boss wind up 3 combo move. And right here below you can see it did so. Then in the simple for loop, it says print for inventory for item in inventory. This will sort through the list, giving us all of the items. And then finally, we're in the main menu where it says type play to start or quit to exit. I will type in play. And then it loads level 1. If I typed quit, it would have printed saving game, shutting down, and if I typed in neither of those, it would have said invalid command, try again. Lesson 9, RNG and loot tables. It's time to introduce RNG, random number generation. In lesson 9, we looked at how games generate random loot drops and how to count that loot. We already know about shortcuts and chaining, so let's jump straight to the random module. Python doesn't load everything at once to keep things fast, so we have to explicitly tell it to bring up a random module by typing import math at the top of our code. Once we do, we can roll virtual dice with rand range or pick a random item from a list using choice. What happens when a monster drops 50 random items and we need to count them? We use a dictionary. We loop through our dropped items. If we've never seen the item before, we add it to our dictionary with a value of 1. If we have seen it, we use our shortcut operator plus equals 1 to increase the count. Now let's add on to the Python. Alright, now that we're in the Python, we can see how it works. Notice line 1, import random. This gives us our RNG powers. In this for loop, we use the random.choice loot table, which randomly chooses 10 items from the loot table. And then down here is where the magic happens. We loop through the drop. If the item is not in our inventory count, we add it and set it to 1. But if the else statement is triggered, it means we already have one, and we'll just add on to the existing number of items that we have. So let's see this run. Here below it says our loot summary. We have 1 health potion, 8 gold coins, and a rare gem. So when it randomly chose from our list, it must have chosen 1 health potion, and then it went through the list again and managed to get 8 gold coins and 1 rare gem. If we were to run it again, we would see we would keep on getting different loot summaries, since the random function theoretically randomly chooses the items in the list. And then down here you can see that for index is key enumerate, we have the index, it chooses which item it's in and whatnot, and the enumerate sorts our items from the loot table to look nicely in our slot. Lesson 10, installing expansion pack aka modules. Lesson 10 is all about expansion packs. In Python, we call these modules. Python is a massive language, but if loaded every single command every time you booted it up, it would be as slow as a game with a 10-minute loading screen. To stay fast, Python only loads the absolute basics. If you want fancy stuff, you have to import it. We place import statements at the absolute top of our code. If you type import math, you get access to advanced math commands. If typing random or math over and over again gets annoying, you can give them a nickname using an alias, like, for example, import math as R. Instead of having to type random over and over again, we can just type R. Finally, did you know every script you write is a module? If you write a great damage calculator in one file, you can literally type import my underscore calculator in a brand new file and use your old code. So now let's go to Python. Alright, now that we're in our code, I'll show you exactly where to put these import statements and how to roll a critical hit using math and random modules. At the top, we imported math and we imported random as R because we used the alias when I want to roll a 20-side dice on line 10. I wrote r.ranrange 1 through 20. Instead of having to type in random, we just use the R. And the 1 through 21 represents the 20-sided dice that we're going to use. If we roll a 20, we get a critical hit. Math.pow is just using to the power of something. So we have the rounded damage, which is down here. You can see the math.ceil that rounds up the base damage to 26. If we rolled a 20, we'd have 26 to the power of 2, which is, in other words, 26 times 26. And then it would say, critical hit, you dealt critical damage, massive damage. And if not, then it said, you hit for round damage, which is our base damage rounded up. So let's see the code. Run. As you can see here, it says our base damage is rounded up to 26. We rolled a 12, so you hit a 26 damage. Now, it would take forever to keep on trying to roll a 20. So I'm going to quickly type in our code to generate 20 so you can see how it would look if we did. It says our base damage rounded up to 26. We rolled a 20, so critical damage. You deal 676 massive damage. Lesson 11 Programming Custom Macros or Functions. Welcome to Lesson 11. Have you ever played a game where you bind a complex combo to a single key? You press X and your character automatically jumps, spins, and attacks. In Python, we create custom combos using functions. A function is a reusable block of code. You build it once and it triggers as many times as you want. We start with the keyword def for definition, name our function, and put parentheses around at the end. Sometimes our functions need data to do their job. We put placeholder variables in the parentheses called parameters. When we finally trigger or call the function later on, the actual data we hand over is called an argument. The most important part of a function is the return statement. If a function just prints a result, it throws the data onto the screen and then gets rid of it. If it returns the result, it hands the data back to our main code so we can use it, add it, or pass it to another function. Now let's head on over to the Python. As you can see here, we built our own custom macros. Looking at line 2, we can see def calculate underscore damage is attack, comma, defense. This is where we define the function, and attack and defense are empty parameters waiting for data. Inside the function, instead of printing out the math, we return it to be used. So it says damage is equal to attack minus defense. If damage is less or equal to 0, we'll return 1. Else, we'll return the damage. And then down here, we have attacking the armored knight. It says for a final hit, we'll call the function calculate underscore damage, and the player attack uses the attack, and then the enemy def uses defense. The function is then runs through, returning final hit equals damage. Then we get the boss health equals 100 minus final hit. Finally, it'll print us an F string that says you dealt X damage. The boss has X health, HP left. So let's see the code run now. Okay, it says attacking the armored knight. You dealt 15 damage. The boss has 85 health left. So it took the 50 from the player attack minus the 35 from the enemy defense, gave us our damage, which was 15, and then it put the damage into the final hit, where it was 100 minus 15 equals the health boss, which returned back the 85 we see down below. Lesson 12, customizable loadouts. We are making our functions highly customizable. Think of a character creation screen. If you click next without changing anything, you will end up with a standard brown-haired warrior. This is a default argument. When building a function, we can set parameters to default values. If we don't supply new data, Python just uses the default. But what if you want to let players start the game with bonus items? Some players might want 1 item, some might want 50. We handle this argument unpacking by putting an asterisk in front of a parameter, usually written as asterisk args. We tell Python acceptable as many pieces of data as the user wants and batch them all together. Finally, a quick rule of scope about scope. What happens in a function stays in a function. If you create a variable inside a function block, it's called a local variable. As soon as the function finishes the job and hits return, the local variable is permanently deleted from the computer's memory. So make sure to have different names for local variables and global variables. Let's go on to the Python. Let me show you how it works. So in this function, create underscore character has the name, and right here is our character underscore class equals villager. This is our default argument. It will return back villager if we don't have an argument for it to be named something else. And then the asterisk bonus underscore items sets up an unlimited arbitrary arguments, so we could have as many bonus items as inputted. Down in the main code, we look at how we call this function 3 ways. First, we pass the name Bob, and it'll just return us the default. And then in this one, we have Arthur and Knight. This will give us the name Arthur, and then instead of the class being villager, it'll be Knight. And then finally, there's Merlin, which is a mage, and then these are all of her bonus items. So let's see the code run. Okay, so it says create character Bob. We got the name. It says print character created Bob, and then create print class character class. And since we inputted the name Bob, it returned Bob, and we didn't have anything for character class, so it just returned villager. Then for 2, it says it gave us character created is Arthur, class is Knight, starting inventory is empty pockets. So in the create underscore character, it gets the name Arthur, and then since we had knight instead of it being villager, it gave us back that. Now for bonus items, since we didn't have anything here, since we had 0 items, it gave us the else, which is starting inventory is empty pockets. Finally, here's the third one, which uses the whole function that we created. So it gave us back the name, which is Merlin, then the character class, which is mage, and then since we had extra inputs for the bonus item, it says if is lens bonus items is greater than 0, then it'll print starting inventory, and then for item in bonus inventory, which include all of these, it will sort through the list and print dash and then the item that it has. So down here it says starting items dash magic staff, spell book, mana potion, and old hat. Lesson 13, we're looking at strings, which is how computers handle text. If you built a secret password door in a game and the code is Apple, what happens if the user accidentally types uppercase A, Apple, and an extra space? The computer will say the password is wrong. To fix this, we use string normalization. We clean up the player's messy input by attaching a dot strip parentheses to remove accidental white spaces, and then a dot lower to turn all the uppercase text into lower. We can also search and modify strings. To dot find parentheses will tell us exactly where a letter is hiding. Dot replace will swap out words perfect for building an in-game chat filler that automatically senses bad words. Finally, dot spill will chop a long sentence into a neat list of individual words, and dot join will glue the list back together with a single string. Let's go over to the Python. Now that we're in the code, I can show you this in action. Inside our filtered underscore chat function, the first thing we see is a dot strip. This will get rid of any extra spaces the player accidentally typed. Then we check if a toxic word is in the message by using the dot lower. So if noob is in the all undercase clean message. If it is, then we will replace it with a friendlier word using the dot replace function. Now at the bottom, we use the dot split function to chop up the final filter sentence in a list so we can count exactly how many words the player typed. So let's see this in practice. So as you can see here, the player underscore chat has a lot of extra spaces. You are such a noob with more spaces. So down here it says original messy chat. It pulls in the variable from here and prints it out, as you can see below. Then we'll have the filtered is equal to filtered underscore chat parentheses player chat. So it uses this variable from here and puts it into the function at the top. So the user underscore input dot strip gets rid of all the extra spaces and gives us a clean message. If noob is in clean message dot lower, which it is because the noob is in here, then it'll give us clean message dot replace noob with friend, and it will return us the clean message. Now the clean message is put into the filtered, where down here I'll print out filtered clean chat is equal to filter, where it says now you are such a friend. Now in the word underscore list is equal to filtered dot split, and then it will show us that it will split the text into individual words, like I said, and we can now use the lens function to find out how many words was or were in that chat or string. And it says the player said 5 words. And then down here, we print the word list looks like this. And then it shows you are such a friend. All right, and that's all the code that we learned from lessons 7 to 13. Thank you for watching. Bye.